Okay, today we're going to talk about the hyperbola. So you can see with the hyperbola, it actually has two parts. Definition, it's the set of all points such that the difference of the distance between any point xy and two foci is a constant. So if you took a point here and you took the distance that point is from that foci and that foci, you will get the same answer. Okay? Okay, so the thing with a hyperbola, it has all these parts. So you'll see in your notes, it has a center. So the center is actually where your asymptotes go through. It has vertices, which your vertices are, if you have a squared, you'll see that the equation is subtraction. You can sort of write this stuff in as you go, but if this was a squared, I would square root that and I'd go this many spaces away from the center. The foci, you add. So the equation has subtraction, but with the foci, you add. With an ellipse, the equation had plus, and you subtracted for the foci. But with an hyperbola, a squared is always first. Now, the strange thing I think that people mess up is when x squared is first, the hyperbola is on the x-axis. But so it goes sideways. What confuses people is usually an x squared is a right side up or upside down parabola. Well, these are going to be sideways. When y squared's first, it's going to be on the y-axis, not necessarily on the y-axis, but you're thinking horizontal and vertical. X squared is horizontal, y squared is vertical. Foci, number of spots from the center, those would be those dots if you're looking at that picture. Your vertices I already talked about would be there. Transverse axis is the way that it is the primary axis. So if x squared is first, this is the transverse, that's the conjugate. If y squared is first, that's transverse, that's the conjugate. Asymptotes, they help you draw the hyperbola. Because if I drew that better, your hyperbola should get closer and closer to those asymptotes. So it's sort of like those asymptotes are a sketching aid. And they make that box inside. So that is the stuff that should be in the box. That's also in the notes that you see the PDF of. But big thing is hyperbola is subtracting. X squared first, it goes sideways. Y squared first, it goes up and down. So now we're going to look at some examples. So first one, you have that. So what I think of drawing it, find the parts and think of how it's going to go. X squared is first, so I know it's going to be on sideways, going to the right and to the left. Center, always take the opposite of the x, the opposite of the y. 1, 3. Okay, that's the center. That's where your asymptotes are going to go through. Now, I forgot to talk about the asymptotes. The asymptotes, which I should put on the other page, to find your asymptotes. Now, I do this, like if you look in Khan Academy, it's probably not going to be this way, but I do it from the center. So what you always do, so when you're thinking of asymptotes, it's always rise over run. So you want to think you're always going to square root the y squared number over the square root of the x squared number. And what you then do with that is you do the slope from the center, rise over run. So like for this one, this is 4, that's 4. So my asymptotes are going to be the square root of the y number, which is 2, and the square root over the square root of the x number, which is also 2. And really that's 1 over 1. So I'm going to go up 1 over 1, down 1 over 1, up 1 over 1, down 1, back 1, and there would be my asymptotes. Now, sideways, since the x again. So this number square rooted is the number of spots from the center. So I'm going to go 2 spots from the center, and there's my hyperbola. Foci, c squared equals a squared plus b squared. So 4 plus 4 is 8. Square root it. Square root of 8 is 2.83. So that's 2.83 spots from the center. 1, 2.83. 1, 2.83. I usually don't make you give me those coordinates. If you can draw them in the picture, it's a lot of moving parts. So if you have the picture, I'm good. So second one. Okay, this one's a little bit easier. Center is 0, 0. Y squared is first. So that means it's going to be up and down. Do your asymptotes first. So think the square root of 9, always the y number over the x number, the square root of 25. So really what that means is I'm going to go up 3 over 5, up 3, back 5, down. It makes that little rectangle thing. And that's going to help you draw this hyperbola. So where are your vertices? 3 spots away from the center on the y, up and down. So there is my hyperbola. Where are my foci? 9 plus 25, square rooted, which is 5.83. So I would go up 5.83 from the center, down 5.83 from the center. So it's just 2 dots in there. So writing an equation. When you're thinking of writing an equation, I say find the center first. So I also say what should be first. Well, number 1 is right side up and upside down. Y is first. The center is at 0, 1. So I'm thinking my Y center is 0, 1. That means that gets the 1. X gets the 0. Okay, so now you need the numbers. Well, you're going to get those numbers by doing either using the asymptotes or using the number of spots from the center. So if you look at your picture, if you sort of counted from 0, 1, to get to a vertex, it's up at 5. So that means that's 4 spaces. 4 spaces away from the center, up and down. I'm going to square 4, gives me 16. Now, to get the x number, look at that little box. So if you think of like where that center is, you went up 4, and where you hit that point over there is going up 4 and over 2. Well, if I went up 4 and over 2, my 4 squared gives me my 16. My 2 squared gives me 4. I'm done. Okay? Next one. I'm sort of trying to go quick so the video's not too long. Next one. Vertices are 0, 10, 0, negative 10. I would draw it. 0, 10, 0, negative 10 means I'm there. Well, that means y's first. What's your center? If you look at the picture, 0, 0. Y first, which you don't have to put the 0. So you got that. 10 spots away. That's 100. Now, how are you going to find the x? Well, think of when they say the endpoints of the conjugate axis are 6, 0, and negative 6, 0. So really what that means is that's that box that went like that. So you went up 10 over 6. So square 6. There's your equation. Okay. Next one. Center is at 2, negative 4. Transverse axis is horizontal, which means it's going side to side. X is first. So x minus 2 squared, hyperbola is always minus. Y plus 4 squared, you always got equal 1. Now, the central rectangle is 8 wide and 24 tall. So really what you want to think, and there's just a trick to this. I drew that wrong though. That's those asymptotes. So if you think, if that's 8 wide and that's 24 tall, the center's in there. So you want to think, well, how much did I go up and over to get that? Well, if that's 8, that means that's 4. If that's 24, that means that's 12. So you end up just dividing them by 2, but put them in the right spot. 4 is this way, which is x. So that's got to be 4 squared, 16. 12 is this way, or 24 split in 2. That's up and down. Square 12. There's your equation. Okay? Last one, you got to find the middle. So with a lot of this, you guys will see me. I draw these pictures because it just sort of helps me. Negative 1, negative 10. So I think of that. And then negative 17, negative 10. And the conjugate, those are my vertices, which means my center's got to be there. And it means x has to be first. I know you can't really see that, but if that's negative 1 and that's negative 17, that's 16 numbers. 16 numbers split in 2 is 8. So that means you're going to go 8 that way, 8 that way. Well, 8 away from negative 1, negative 10 would be negative 9, negative 10. That's my center. Sideways, x is first. X plus 9 squared minus y plus 10 squared equals 1. Now, that's 8 spaces, 8 spaces. That's the number, and that's underneath the x. Square that, 64. So then when they say the conjugate axis is 10 units long, that just means, again, this rectangle. Well, if that is 10 units long, that means each of those had to be 5. Square 5, 25, you're done. So I'm sure we'll have questions on the hyperbola, but that's the lesson for today.